examples on this one, but they don't take a whole lot of time, and this is work. And in case you haven't done physics, which I haven't either, just to let you know, work is measured in foot-pounds in the customary unit and then joules in the metric, so just keep that in mind. Labeling might be difficult for some of you if you haven't taken physics, and that's fine, but just try to label them correctly. So you can use vector projections to see what's work done by a force. So a work done W, let's say that's what the work is, by a constant force F is acting along the line of motion is the magnitude of the force times the distance traveled. So it's saying you're going to take the force times the distance traveled, and that's all you do. So this is really, really easy on these first two examples. Okay, so determine the work done by pushing a 500 foot-pound crate. I said 500 foot. 500 pound crate. Well, that's the F. And the 12 is the AB because that's the distance traveled. So you're literally going to take 500 times 12. And that's 6,000. And since it says pound in feet, that means we're in the customary unit. So the answer is foot-pounds. And you can either write that out or do that. I don't care. Okay. So on number 7, it says determine the work done by a crane lifting a 2,300 pound car 5 feet. So the work is 2,300 times 5. If you put that in your calculator, that's 11,500, and it'd be, I'll write it out this time, foot-pounds, because we're dealing with the customary unit. So this is customary is right here, okay? So what happens if there's something else going on? So if the constant force F is not acting along a line of motion, and that picture is not the right one, so I'm going to have to draw something, which is not good for you. All right, so let's make this arrow here and a dotted line here. Okay, so I'm gonna have to relabel this stuff because I used the wrong image when I did your notes. So ignore this. F goes here, and this is the projection vector. And that's subscripted, and F goes here. Okay, and that's important for what we're going to do later. So I'm going to reference this on the back side. So go ahead and write this down. If you need to, pause the video. And I wrote this down wrong. Wow, okay, hold on. Don't write this down because I wrote that down wrong. Okay, so the projection form is, oops, wow, struggle. W equals the magnitude of the projection vector times the distance AB goes. And that's the dot product form. So that's what you want to write. I'm going to go to the other page, but I'm going to come back to this to reference it. So if you need to pause it, do it. Okay, so a man pushes a car 8 meters with a constant force of 140 newtons. Notice how it says meters. Right away, we're not doing, this is the metric system. So we're going to be dealing with joules. Okay, so a man pushes a car 8 meters with a constant force of 140 newtons at a constant angle of 50 degrees. Use the projection formula to find the work done. So if there is an angle involved, you do things a little bit differently. Okay, so in this situation, the first thing you're going to do is find out cosine of theta. Okay, now cosine of theta, just to show you, is adjacent over hypotenuse. Well, in this situation, this is the adjacent and this is the hypotenuse. So we're going to do the projection of F over F. Okay, so I'm going to write that down. And we need the magnitude of it over F. Okay, well, there's a little bit more work involved. So the whole thing is asking you to find the projection formula, right? And this has it in there. So if we were to multiply this over, it would say cosine of theta times the force is going to give you the projection formula, correct? So then we can fill out the information we actually have because we don't have this information. We're trying to find it. So the angle given to us is the 50. That's not in your unit circle, so you have to calculate that. And the force is the right here, the 140. So I'm going to put parentheses around this. So if you calculate that, which you don't really need to do right now, I'm just going to leave it as is. That is the projection thing. Okay, so then you have to keep going. So you're using the projection formula, so this is our new projection formula, to find the work done. So the work says that you have to take the projection, and if you notice I'm not subscripting because I just don't have, you can't even tell what I'm writing, so I'm not doing it, times the distance traveled, and we're done. So the only thing that's difficult is we had to find this. So that's the most annoying part about it. So you take, and I'm going to write it as a whole, but I'm going to write this 140 first because I just worry that you'll calculate it wrong in your calculator. Make sure your calculator's in degree mode. And then the distance traveled is at 8 meters. So when you're doing this, I would just kind of cross off the information we used. Right here, we use the 140 and the 50, so 8 is the last thing we're going to use. So multiply it by 8. If you put that all in your calculator, you get 719.92, and it's in joules, like I said, because we're in the metric system. Okay. If we're in the customary system, it's foot-pounds. All right. And that's going to lead us into number 9. So it says Rick is pushing a snowblower with a force of 90 pounds. The handle of the snowblower makes a 60-degree angle with the ground. How much work does it need to do if he pushes the snowblower 15 feet? Okay. So do you notice how it just says how much work does he need to do? Okay. With that one, you can use the dot product. With the one below it or above, it says use the projection formula, and that's why we had to do the projection form. So on our notes right here, one says projection form and one says dot product. Okay, so projection form here, okay. If they ask for it, that's the method you have to use. If it's dot product, it's a lot less work. So we're going to be using the dot product one. And that rule is W equals F times the dot product of AB. Okay, so the 90 pounds is going to be the number in front of, hopefully you guys remember this. It looks like this. So 90 cosine of 60 degrees. You might have to throw it back to, the dot product. Okay, so that's what we ended up getting out of that. That part is the force. Okay, we did that with the dot product and all that fun stuff. All right, then the AB part is going to be how much he's moving. Well, he's not moving vertically. He's moving horizontally, so it's going to be 15, 0. Okay, so that's the 15, 0 part. That's the AB. This 90 and the 60 is going to be that force you need. So then you just multiply everything together. So you get 90 cosine of 60 degrees, and it'll be times 15, plus 90 sine of 60 degrees times 0. Well, that's going to be 0, so we don't even need to worry about that. So if you type in your calculator 90 cosine of 60 degrees times 15, I forgot that part, that made a huge difference, you get 675, and since we're in the customary unit, because there's pounds, it's going to be foot-pounds. All right. That's all I got for you. That's the last video. Best of luck. Let me know if you have questions. Stay safe, stay healthy.